Hey, what's up everyone? Welcome back to our video series on Active Directory Red Teaming, TTPs. Today's topic is going to be on Kerberos Delegations. So what is Kerberos Delegations? This dates back to Windows 2000 server when AD was first introduced. And the reason for that was because let's assume you have a web application that talks to a back-end database server. So a user authenticates to this web application using their Kerberos authentication or credentials, right? So we go through a typical Kerberos authentication, request TGT, get TGT back with a session and all that, right? And then the user needs to do something on the database server, right? So instead of re-entering their credential on the database server, the web application service can actually act on behalf of that user and then talk to the database server, hence impersonating the user. All right. So if you want to understand or have like just a layman's term for delegation, it's just basically impersonating or delegating my responsibility to someone else, right? So it was meant to remediate what we call the double hopping issue, which is being able to jump over or between systems using the same user Kerberos credentials to achieve that, right? Now, we have types of them. The two most well-known ones are the Unconstrained Delegation and also Constraint Delegation. Now we have the resource-based constraint delegation, which I have that in quotes because that is still fairly new and it's a little bit difficult to explain how it is, but that would also be part of our video series in the future. But for now, the two most well-known ones are the unconstrained delegation and the constraint delegation. In this particular video, we are going to focus on the constraint delegation piece of it, right? So let's do a quick recap on the steps that go behind the scene for this particular attack to work. So the user authenticates with their credentials, the username and password, and then requests a TGT from the domain controller, which in this case here running the KDC. The user gets back a TGT with a session key from the domain controller. All right. The third one is the TGS request from the user. Okay, so the user presents their TGT to the KDC to request a ticket granting service ticket for the web service. Okay, which is normal, the normal ones, right? And then the person gets back the ticket with auth, which is the TGS. It's encrypted with a web services NTLM hash, password hash. Remember, we talked about Kerberos, right, in our previous attack. So this should be familiar to you, right? So now the fifth step is the user presents the TGT and the TGS to the web server, which is this one right here. So the web server gets this ticket, all right? And then we have to request a TGS from the database server. So then the web server service account uses the user's TGT to request a TGS for the database server. So this is impersonating this user to request a TGS from here for this service. The sixth step, which is the most important one, is this web server service account will take the user's TGT to request a TGS for this database server. And normally there should have been an arrow going back for, let's say, step 7, but it doesn't matter. You get the point. The second and the seventh point is once that now we have the TGS for that database server, now the web server can connect to the database server on behalf of this user, hence impersonating this user. All right. Of course, this sounds crazy, right? Microsoft had a good intention for the delegation, thing, right? But of course, the bad guys had different mindset, all right? Because if we can compromise a server which has, let's say, this web server, which has unconstrained delegation on it, then we might be able to use this user's TGT to request a TGS for this database server or for any server that that particular user has a privileges on. And that is a crazy part of that, right? So then that comes in the unconstrained delegation. What makes that so bad is that user, if they have privileges on other systems, they can authenticate to those other systems using any service protocol. So that is why I have that here in red. Okay, so for instance, if let's say the user doesn't have just access to, let's say, the database, but also have privileges on other servers, which will demonstrate, then that user can access those servers or systems through any known protocol that works on that system. Okay, so how do we identify systems with unconstrained delegation? Well, one of the key factors or the key flags we want to see in a system when they have unconstrained delegation enabled is the trusted for delegation flag in the user account control attribute. All right, so again, if you see here, the DC places the user's TGT inside the TGS, which is in the fourth step that we have talked about, right? So when the user presents the TGS to the server with unconstrained delegation, which in this case is the web server, the TGT is extracted. The TGT of that user is extracted first by the first server, which again is a web server, and then from the TGS and then stored in the LSAS. So we would actually extract that particular TGT and then use it to request a TGS so we can authenticate to other systems that this user has access to or privileges to. That is the whole point with unconstrained delegation. Okay, how bad it is? Well, if let's say a domain admin or any high privilege user has access to that particular system, we can extract the TGT to request a TGS for any systems on a domain that they have a privileges on. Okay, so let's go into demo and then let's see how this works. Okay, so in this particular video, we have sequence of activities we are going to execute to demonstrate how we can abuse unconstrained delegation. First of all, we are going to show how we can take advantage of a misconfigured Jenkins application, web application, and how we can leverage that to execute reverse shell into our C2 framework, and then take that from there to further move within the network to compromise a domain admin account, hence compromise domain controller. So let's jump into it. So this is my Kali box, and I have my Covenant C2 framework running. The target web application is a Jenkins server running on port 8080, and the moment you go to that application, because we have anonymous authentication enabled, it gives us right access to the dashboard. Now, if you're not too familiar with Jenkins and how we were able to set up this environment, I would encourage you to look below the video description. I think I have a link to my playlist that shows you how we designed this lab environment for this particular attack. Okay, so now that we have access to the Jenkins, one of the things that we can abuse within Jenkins is we can use it to build jobs. Now, when we say building jobs, when you build jobs, those things they do actually execute on a backend server. That is a bad idea, right? So in our case, let's demonstrate how we can abuse that function and see if we can create a job, and then what can we do further from that. Okay, so let's type in Jenkins jobs and click on freestyle project, and then we'll click OK. And that should take us to our Jenkins job dashboard. We are going to scroll all the way down and go to build. We are going to select execute Windows batch command. And just for test purposes, let's see if our job does work actually. So let's type in, let's say ipconfig, and hit apply and save. And let's hit on build now. What is happening right now behind the scenes is this Jenkins application is running our job. What I mean by running is it's actually executing the code that we did put in there. So we'll see the output. So now that we have this as blue, we can click and then go right click and then go to the console output. And yeah, sure enough, if you can see, our ipconfig did execute behind the scenes. So we've actually been able to demonstrate we can execute remote code from Jenkins dashboard. The bad thing, even worse with Jenkins, is these commands do execute with system level integrity. That is the highest you can think of when it comes to compromising a server, is actually being able to have a system level privileges on it. Okay, now this is just a tip of an iceberg. Here, from here going forward as an attacker, there are vast amount of ideas that you can use this misconfiguration to accomplish your goal. For the purpose of this video, I'm going to show how we can generate a launcher from Covenant, launch it to get a remote reverse shell into our C2 framework, so we can begin our attack against the unconstrained delegation configuration on a Windows machine. So let's go back to the project and let's click on configure, and let's head all the way down to our code, and let's go back to Covenant, and we are going to generate a launcher. Once you get into Covenant, you have so many options on how to generate a payload or a launcher. In this case, let's stick with PowerShell. And then these are the options we have here. We even have a kill date and all that, right? So then we have to hit on generate. We have options. You can either generate your code and even download it and move it or host it somewhere else, right? Or just execute it directly within wherever you want to execute. So in this case, for the sake of simplicity, let's just copy that and then go into our build and then paste the whole code here. And as you can see, this is going to execute PowerShell and our code, hide the window and the entire code, the launcher, for a reverse shell into our Covenant framework if we're so lucky. Okay, so let's click on apply and let's hit on save. And then one more step, let's hit on build now, and let's pay attention here. So it looks like it's building. Let's go back to our Covenant, and it didn't take too long for us to get a grant. In Covenant, whenever you have a session on a system or whenever you get a session coming back to you, it's called grant. So if we can go into grants here, and we'll see everything that, all the sessions that we have here. Lucky enough, the host machine that we have compromised is called Web02. It's running with system, I told you, and the integrity level is system. We have two options that we can communicate with our session. We can click here, the drop down will give us this view, or we can select the name of the grant to get more information about that session. Okay, and we can go into interact. And the good thing with Covenant is, if let's say there's a command that you don't remember, the moment you begin to type something, you have a list of stuff. Okay, that is fantastic with it. So let's hit on who am I and then see what user context we are running with. And again, we're running with system. So that is good. We have accomplished our first step of establishing a reverse shell on our server. The next one is enumeration. Let's see how can we find a system that has unconstrained delegation enabled using, of course, PowerShell. Now, one benefit and one good thing with Covenant is we can import any PowerShell script and then run with. So the one that we want to import is going to be, we're going to import Power View. And I have it downloaded, so I'll click that and then open, and then just simple PowerShell imported, right? So that is good. And now we are going to go ahead and enumerate for such systems. But before that, let me point something to you. You see how we type in stuff here and then they come up, drop down and all that, right? There's another option that we can communicate with or execute tasks within Covenant, and that is going to this tab here. And everything that we're running on the command line are also here. Okay, so for instance, if we want to say list process, we select list process and then hit task, and that is going to run it the same way that we may have, if we had typed it here as well. That is very, very nice, because maybe there are some commands that you may not be familiar with and you want to play around with. You can always go to task, and then the tasking is the various tasks that you have already done. So let's say you've done something that you have forgotten, what kind of tasks that you run, you can always come here and you have all of them here. Okay, so we have PowerPoint and Power View imported. So let's see how we can find any server on a domain with unconstrained delegation enabled. So to find that, let's type in PowerShell, and then we are going to type in get, and let's see. It looks like it did work. Okay, good. So we are looking for unconstrained delegated delegation systems. We can see one here, which is the GHDC01, which is a domain controller. You'll find that on almost every Active Directory. The domain controller would always have that enabled. And if you remember, I told you about user account control, and we have trusted for delegation enabled. Okay, I would always tell you we are not going to look for domain controller for this one because we don't have access to that yet. Otherwise, the whole point would have failed, because we're looking for ways to actually escalate to that of a domain admin. So if we can actually do that on a domain controller, then there will be no point for us to abuse this. So let's go down and see if there's any other system beyond domain controller that we may be able to gain access to and then abuse it. And as you can see, the next one is here, and it's actually the system we have compromised has unconstrained delegation enabled, which is the web 02. And let's see, yep, here it is. The trusted for delegation is down here. All right, so lucky enough we are on that system. So then what can we do? Let's get into our next phase of attack. Is we need to have a user with a higher privilege on this system with a session that we can actually, once we have been able to extract, we've been able to generate a TGS for that particular high-end user, we can leverage to gain access to other systems. There are a few steps we have to take. First of all, we need to find out what tickets are currently on this system, because at the end of the day, those are the ones that we are going to request and then use that to generate a TGS. So within Covenant, we can just type shell cmd and then klist, and whilst that is running, we can use rebuild klist as well. And let's see, we are going to get an error, I believe. Oh, we did not. We did not. Oh, that's nice. Oh, Yes, I know why. All right. Yeah. So the reviews, for some reason, we do get error with the reviews. And the thing that I came to find out was because we are running with a system in, account or user. But if we are using, let's say, a domain account, then reviews works fine, right? So let me see. Just give me 1 sec and I'll show you why. So let's see, process list, and I'm going to show you, we are going to impersonate a user on this machine and then run reviews klist again, so you see the difference between tools, right? Because the klist is a built-in utility within Windows and that works fine, right? Fantastic. And yeah, everything that we see in here is just the web service. That is not of interest to us for unconstrained delegation, but we do see that we have T Sankara here that we probably will be able to impersonate that user. The beautiful thing is, let's go back to task, and so I was showing you how we can use both. We can impersonate a user, and it's going to be, let's say, GHT Sankara. And if that is successful, we can become that user. So if we do who am I, and let's see, who are we now? Yeah, we are T Sankara. Now let's try to run reviews again, klist. The downside is you guys will see in a minute. All right, so as you can see, that did work, but it only worked for that user T Sankara. We want it for every user on this box. If there's any session here from a domain admin or somebody with high privileges, we can still dump the tickets for T Sankara, but we don't know if that user has privileges on other systems, right? So let's revert. If you want to get back from impersonation, you can always go back to revert to self, and that will take us back to being system. As you can see, we are now back to system. Okay, so we are still working on the assumption that we have compromised a server that has unconstrained delegation enabled, and a domain admin has a session on that box. When we say a session, it doesn't mean that they have logged in interactively on the machine. Anything from remote to the web, to the web server, would actually record a Kerberos ticket on that machine, and by virtue of that session from any remote server to the web server, we'll be able to extract a ticket for that particular domain admin and then use that to compromise a domain controller. So that is the assumption here. Again, we have a system, but how can we get all the tickets on that machine? You have seen us using reviews, and when it has a system context, it doesn't give us anything. It gives an error. When we impersonate a user on the system, it only gives us the ticket for that current user, because the user that we are impersonating the session doesn't have an admin privileges. Even though T Sankara is actually a domain, a local admin on this machine, for some reason, again, when it comes to tool limitation, this is where you see those things. So if I type shell cmd and net local groups administrators, you see that our user has belongs to the local administrators, which is a T Sankara. But trying to, which is, of course, we can now escalate to that of a local admin, so we can have all the tickets on that machine, right? So that user is a local admin, but when we do impersonate, it only takes the medium integrity of that user, which is not able to get all the tickets on it. If we do, again, let's run the local Klist. Now this is running under the context of a system user, okay? And that one has, so we're looking for something else beyond this. So if you can see, it's not even seeing T. Sankara's ticket, okay? Because it needs a user with administrative privilege on that machine so it can get us all the relevant tickets on this machine, right? So how do we do that? Well, as an offensive operator, this is where your thinking comes in. You have, for goodness sake, you have a system level access on this machine. You can do whatever you want for priv escalation. So let's take one way which I wouldn't recommend for you on an actual engagement is let's change a user's password on this one for admin, privileges. You can create a backdoor user and then put that user within a local admin and then obtain a session from that user onto your C2 infrastructure and then see if you can get additional tickets. In this case, I'm going to take a route which I would not advise anyone to do, CMD and net. And I think we have, let's change the password for the administrator user. Okay, again, I would not encourage that on an actual engagement, but this is just for the sake of demo purposes and for the sake of trying to reduce the amount, the video time to something reasonable. I don't want to extend it, trying to jump through all the hoops. Otherwise, we'll lose focus of the main intent for this video. So let's change the admin's password. Fluffy1234. Nope. Whoa. Net user. Okay, and let's see if that one works. If we can change that user, now we can use a way to get a reverse shell onto our C2 infrastructure with a newer session with an admin privilege and see once we dump the tickets if we find something different. Okay, so now that that has been successful, let's confirm that. Let me take this over to our Kali box and use in packet. So essentially what we're trying to do here is we want to set up another session with an admin level and see if we can get different tickets, because so far we are not happy because all we're seeing right here is just tickets for the web service, and the other one is for T. Sankara, which we're not looking for that. We're looking for someone else or any other high end tickets on this box. So now that we've been able to get a command shell here, let's generate a launcher. Let's copy our launcher and let's copy. Okay, and see if we get any connection back. Yeah, we do. And now let's look at that integrity. Okay, so now we have an admin and it's a high. So let's go in and see who am I. And now let's run the Klist again and see if we'll find something different. The reason why I'm doing this is I want you to see some of the variations depending on the level of access you have on systems. You may be missing something because of the type of user level or integrity level that you have. System is good, but sometimes it may not be useful to to instances. So let's see if we do Rubius again. I do Klist. Now let's see if we find something different from the previous session with the system. Okay, so now you see, so now that we have an admin level integrity or high integrity with an admin user, the Kerberos is giving us all users. This is what I was looking for. We need to find all users on a system. Now, what does that mean? Now we see a user here who is the LN Mandela, and we see the ticket, which is what we are interested in. Okay, we have T. Sankara, and of course we have the web service, right? So again, I hope you're getting the point here. The point here is sometimes you have to keep hunting, think outside the box to be able to find certain things, because sometimes some path may be so simple, but it may not be that simple. Sometimes you have system level and we believe that is the highest and we are all good, but we may be missing certain things because we may have to try some other way. So now that we are using an admin level with a high integrity level, now we can we can dump everything on the system. Okay, so the goal here is we are going to dump all the tickets on this box and then use Mandela's TGT to request a TGS, and see, once you've been able to request a TGS and then inject it into our session, we'll see if we can compromise the domain controller. The reason why we have Mandela, we are so excited, is if we do shell cmd and then we do net and then we do group, we'll see that Mandela is a domain admin. And if you go back to this, to the slide I told you, that is where if a user mistakenly has a session on this box and it's a high level user, oh yeah, I'm using a non-domain joined user account, which is the admin. That's why it's not able to find it's not able to talk to domain controller. All right, so yep, so I'm not a domain user, I'm just a local admin. So that's why it's not, I'm a local user. That's why I'm not able to request information from the domain controller. But the point is, we know that that user is a domain admin, and we are going to dump the tickets and then use that to request TGS. Okay, good stuff. So these are things that we used to do them manually, but Rebios had made it very, very easy and simple for us, right? Look at the sheer amount of options we have with Rebios here, right? So the one that we want to use here is going to be the dump. Where is it? Rebios dump. Yep. Let's dump everything, and it's going to give us the tickets on this box, and it's going to give them in base 64 encoded version, and then we'll use that to request to perform a pass-through hash. To request a TGS, and then use that to inject it into our session, and then access other systems. So if you can see, we have Mandela's here, and this is the base 64 encoded ticket. We have the one for T Sankara and the base 64 encoded, right? And it's of course the same thing with the web servers, which we don't have any. So now that we have been able to dump the tickets, the next one is to use Ruby's pass the ticket, which is the PTT, to pass that ticket to request a TGS. So let's copy that. Base 64, oops. Let's copy, and let's go to task and look for Rubius, and we are going to type PTT, which is the pass the ticket, and then we are going to give it the ticket, and let's paste. Now, I hope some of you guys caught this. This is where it gets a bit of a problem. So there are spaces from our the ticket that we cut from the interactive session. So we need to remove all these spaces, otherwise we'll get an error. Okay, so I'm going to remove all these tickets. Okay, so once you have all the spaces removed from the TGT, now we have everything set up. So let's hit task, and hopefully if you come here, this is how it's going to look like. Rubius, and then the command is pass the ticket. We provide the base 64 encoded ticket to that, and then once everything come on, the ticket X needs to be supplied. What did I do wrong here? Oh, look, I misspelled ticket. Shame on me. All right, so let's go. I have to go through this long line, and I can fix it here. Ticket. I got it right. Okay. So the reason why I'm showing some of these failures, with this kind of thing that I'm doing here is this is not a Hollywood movie or Hollywood show. Okay. Even seasoned operators would always find difficulties in our work. All right. Otherwise, our job will not be excited. Right. So if you're looking for videos where everything is just perfect, showing you how to do everything perfect, then I'm sorry, this is not the kind of video, because I know there are some videos that you will see that they will show you everything that works throughout and wouldn't show you some of the glitches that comes along. I think as much as those are done to cut the time, I think sometimes it's good for you to start see things like this so that you realize that it's not all that golden with our line of work. Some things may not work. Some things that you used to work for you may not work at the time of the need. And trust me, we have come across so many of those instances, right? And so you can see that we have, I have shown you some ways that even though you have a system level access, some things may not work within that context, and you have to think outside the box, right? So when I do my videos, I tend to leave some of these glitches or some of these challenges in the video, not to discourage you or not to show that I don't know what I'm doing, but to let you also understand that our work, these are some of the things that makes our job exciting. Okay, otherwise you won't think outside the box. If everything is just easy peasy, it wouldn't make the job exciting. And it's not true in the real world. You would always find challenges. Something that you did yesterday may not work today. And you have to think outside the box. Plus, you're being paid well to do this kind of job. You have to think, right? So, okay, so we can see that the ticket successfully imported, right? So the next is for us to inject this ticket into our session and then see if we can use it to access other systems. Remember, this ticket is for N. Mandela, who is a domain admin on this in this lab or whatever you find yourself in, right? So let's see our tickets shell cmd, and then let's do klist, and if all works well, it will tell us that we have N. Mandela's ticket. Yeah, we do have this user's ticket in our session. Well, the moment of truth, let's see the domain controller. Let's see if we can list the domain controller directory. So now that we have this user's ticket injected into our session, let's see if we can compromise or gain access to the C drive, list the directory within the C drive on the domain controller. How? All right, we have access denied. Can you believe it? But we do have this user's ticket in our session. Okay, so now let's go back to, we still have, the good thing is we have this user's ticket. Okay, how about we copy this whole thing and we use our system session, and instead of running it from the user admin, let's use it under the system and see if we get lucky. Okay, so let's go to tasking, and the same thing with reviews. Inject it into, oh good, it actually has it here. Good. So if we click task, and then it's going to, remember, this is the user that we were working under the, with the system level user account. Okay, it's been imported, and let's do the same thing that we just did. Oops, oh, we don't have it here. Okay, there ghdc01.gh local. Okay, let's keep our fingers crossed. Again, we've injected this user's ticket into our session, and let's see if we get anything different here. All right, there you go. So if you don't know what happened, let's do the same thing here and then do Klist. Do I know why this happened? Honestly, I don't. If any one of you know why the ticket didn't work when we used the admin's session to inject the ticket into our session to list the directory, compared to when we have a system integrity and a system user and then injected the same ticket, but we're able to list the directory, or we're able to compromise, gain access to the domain controller. All right, so if you see, we have the same ticket here. It's the same user. We have them multiple times, but it's the same ticket anyway, right? But for the admin, it didn't work. So we've been able to achieve our goal here. We've been able to breach the web application, gain a reverse shell on the web application. We're able to leverage that to create, change a password for the admin. We're able to list all the tickets, dump all the tickets, discover a domain admin had a session whose ticket was active, inject that ticket into our current session, and then being able to compromise or breach or gain some sort of remote code access to a domain controller, which in most cases is basically us owning the domain, right? So let's do one more thing to show you that we can do more than just listing directory, right? So let's do some PowerShell things and see if we can get much more nefarious here. PowerShell, invoke command. So invoke command and computer, and then ghdc01 gh.foo.local, and then script block. Let's do who am I, and then let's do host name, and then hit enter. Okay, yep. So yep, mission accomplished. We are running under the assumption of the domain controller, and we can execute command on the domain controller. Of course, your imagination is unlimited, right? You can do so many things here. You can do PowerShell command here for remote code reverse shell to your C2, and then essentially gain a command line access on the domain controller. Thank you so much. You have a nice day. Bye-bye.